Hi, let's discuss the next topic, which is LDA, Latent Dirichlet Allocation in NLP, how LDA works, Python implementation of LDA in NLP. Before moving towards the LDA part, I'm going to define two important terms in LDA, which is topic modeling. So, topic modeling is a frequency used approach to discover hidden semantic pattern portrayed by text by a text corpus and automatically identifying topics that exist inside it. So, topic modeling is a natural language processing technique that applies unsupervised learning on large text dataset in order to produce a summary set of terms derived from those documents. For example, the word dog and bone are more likely to appear in document concerning dogs, whereas cat and meow are more likely to be found in documents regarding cats. So you can see these terms are more related to each other and defining the topics here. Okay, when you have seen these topics are given here in this diagram as well, I'm going to define the other terms. LDA algorithm, which is generating topics, classifying words, documents among these different topics according to probability distribution. Note, topic here means just collection of words, not any specific term. For example, entertainment is not a topic here. It's just set of words or set of different topics. Okay, here you can see the document is showing Shakespeare paragraph and this topic proportion are assignment here. Can you see they are relevant to their leveraging colors and giving the pink color, blue color and purple in a several frequency. Now I am assigning the topic here, which is negative, hate, bad and money and other different topics also. These are worth, purse, military, conflict, but they are defining the same topic. So what is the LDA role? LDA helps in discovering the main themes or topics in a large collection of documents. Let's move towards the Python implementation of this part. So first and foremost, I'm going to import necessary files, word tokenization, porter stammer, corpus and everything using the LNTK terms. If any library is not imported in my portal, I'll be using pip install term for this one. For example, you can see this gensive is not there in my system. So what I'll do, I'll copy this term, copy and write pip install and then this library. It will take time, so let's convert into code and let's run this cell. As you can see, this library is now installed in my Jupyter notebook. Let's run this cell again. Can you see now I am not throwing any error on the screen. Now in the next step, I'm going to load the data set from the given sheet. So what kind of data set I'm going to import? I'm going to import a news article from this cell. So for this, I'll have to go to my Jupyter notebook. Let's import from the text file. I'm going to searching my news article CSV. This is the file and I'm going to upload. Can you see this is now showing here in this section. Now going back to the portal and going to write my data equals to pd dot read underscore CSV, and inside this one I'm going to write the file name. The file name is news underscore articles dot CSV. So make sure your data should be in the same folder as your notebook. Let's print data dot head and data dot head and then I'm going to show this part. Okay, so this is the data which I'm going to process this part. Okay, so let's have the quick overview of this data set. Let's take an example from this data set, which we have a collection of news article we want to classify into different topics. So this could be political news, sports news, business news, etc. How do we decide which document is about which topic? Well, we can look at the word they use. For example, word such as ball, player, match, game. If these words appear many times in the document, we can probably take a guess. Okay, but what about the other terms? You will have to classify these terms as well. So I'm going to classify these terms in a different section. Yes, that is the role of LDA here. So we must example the words within to discover the topic, that piece of text. So for example, the word crush could be related to traffic news or financial news. So we say that the topic is latent within the document. We must example the words within to it to discover the topic of that piece of text. A document can obviously contain words from more than one topic, but we make the assumption that it's mainly focused on a single topic with only a few words relating to other different topics. This is our Dirichlet distribution. So we have an understanding of what we mean to latent topics and our Dirichlet distribution. LDA then works as an iterative process where we first specify the number of topics that we want to as k. The first iteration of an algorithm is where words in the document are randomly assigned to one of the k topics. Let's first perform few pre-processing over this text, whatever values we are going to obtain. So I'm going to obtain the word information of this data set. Yes, we have 3 columns: ID, title and content. And later on I'm going to clean this data set. So for this I'll be removing all the stop words. So I'm just importing the stop word and just importing my punctuation tab also. So I'll be removing all the punctuation tab also. So I'm just take just the content of the article, lowercase, and remove punctuations. So what I'll do, I'll create a variable called articles and will convert into lower and apply to the sub article, which is /w means word, /s stand for space. Later on I'll be removing all the stop words over this article terms. So I'll be deploying this articles, which just defined here, and I'm going to include in this keyword where I'm just removing all the stop words. In the next hit, I'm going to remove all the topics and converting into tokenization. So this is the tokenization term. And finally, I'm going to create an stemming for the given set of words and using the porter stemmer everything. So this entire pre-processing will be done in a single piece of code and we will be getting final articles with proper keywords. So I'm going to create this article. Let's see what is the content of this article. Yes, we have the word which is free from uppercase, free from punctuations, free from converted into tokenization, converted into free from stop words, free from converted into stemming as well, and finally we had done this part. Okay, now we are going to convert into vectorization format. For this I'm going to create a dictionary object. Within a dictionary I'm going to create this article. This is the dictionary keyword and unique tokens are assigned to each word. Now vectorize using bag of words. These bag of words will be there, and then doc to bag means documents to bag of words. and I'm going to print this document term, so that we can see everything is just converting into Dagger words. Can you see every word is converting into relevant field? Now I specify number of topics as we discussed there. How many topics we are going to convert? First we are assigning to one of the k topics, then we move to the second iteration where we go through each individual word in the document. We assume that all other words are correctly assigned to a topic. We try to connect the current word we are looking at as topic assignment. LDA corrects the assignment by looking at the proportion of work in the current document assigned to a topic and the number of times that this word is assigned to a specific topic in other documents. So this is going to define the other document, and let's see how LDA define everything in this context. Okay. First, I'm going to specify number of topics. Let's say I'm going to find only 2 topics here. We can change this integer numbers as well. Then I'm going to define a model, LDA model, with this Genesis LDA model, and converting document terms and using the dictionary models, and number of topic is 2, which we defined there. And then finally we are defining this term here. I'm just converting this as number of words as 2. Can you see it's defining only 1 and 2 topics are there, 0 and 1. So for these 2 topics we have these terms. Let's change this sentence and let's see what we will be obtaining this as a 5. Can you see 1 2 3 4 5? So all these 5 terms will be there, their respective number of words. So this shows the top 2 words for each topic and their corresponding weights, which represents the importance of these words in defining the topics. In the first topic, these words are corresponding weights, and in the next topic we have these words as a corresponding weights. Okay, if you will see that, if let's say I'm having number of topics, let's say 4, I'm running this cell, running this cell, and running this cell. Can you see now we are having 4 topics and respective corresponding weights. So now we have top 4 words for each topic and their corresponding weights. Now I'm going to run this, for example 7. So now what we are obtaining, we are obtaining top 5 words, top 7 words for each topic, each 4 topics, and their corresponding weights, with which represent the importance of those words in defining the topics. This is how you can identify your entire keyword and entire document using the LDA. It's a one kind of algorithm. We can use other algorithm in upcoming sessions as well. Thank you.